welcome back. So good news. Good news is you just got a break. Even better news is we've already completed 2 of the 3 sections of this webinar. So math is our last section. Everybody should be good and awake right now, but once you get comfortable, try not to doze off on me again. Math is really, really, really important on the PSAT. The good thing about math is this. There are a lot of studies that have shown that by practicing math, you can improve your score more in the math area than in any other section. So some of y'all are like, oh, math, gosh, I wish I just didn't have to do math. And others of y'all are like, yay, finally math. So wherever it is that you fall on that scale, practice in math really does improve your math score long term. So there are some new terms regarding math with the PSAT. And the reason for that is, of course, because math is really focused on college and career readiness. PSAT and SAT are really focused on college and career readiness all the way through now, and there's a specific focus from types of math that are related to college and career readiness. There's also an emphasis on problem solving and data analysis, and that really ties into that career readiness because problem solving and data analysis, those are real life math issues. And then that big thing about you have a section that you can use a calculator and you have a section that you can't use the calculator is totally new. And when you get to the non-calculator section, the purpose of that is to actually look at your problem-solving abilities. And the reality is this, a calculator does not make you smarter. A calculator makes you faster. And sometimes we use a calculator when our brain is in fact faster than the calculator is. So this really shouldn't be a daunting section for you at all because it's not math that you're really going to benefit from having a calculator to begin with. So section 3 and 4 are both math sections. Remember, section 1 is reading, section 2 is writing and language, and then sections 3 and 4 are math. They are combined for a single math score. So section 3 is your non-calculator section. I know some of y'all are still a little stressed about that. We're only going to do the calculator section today, if that makes you feel any better. You have 17 questions. 13 of those are multiple choice, and then you have your 4 free response, which means you don't have answers to pick from. You just have to create your answer. Section 3 is 25 minutes total. Then you have section 4, and that's your calculator section that you can, in fact, use your calculator. If you're not sure if your calculator is legal or not, you can go to collegeboard.org, and it will let you know what acceptable calculators are on their website. There's 31 questions in section 4, 27 are multiple choice, and 4 are free response. Math section is 45 minutes total. That section 4 is 45 minutes. So you've got roughly 70 minutes of math total, but it's broken out into 2 sections, which is good. I can't imagine sitting still for math. My brain would hurt at the end of 70 full minutes of math. Math directions. So this is one of those things that if you haven't done some studying, you probably don't know. And that is that the formulas that you need to solve a lot of the geometry-related questions and other questions are included in the directions of the math section of the PSAT and the SAT. I can't tell you how many students are not aware of that, and so they have skipped answering questions in the past. They would have been perfectly capable of answering if they could have remembered the formula that they needed to answer the question. They didn't need to remember the formula, they just needed to have known that it was listed for them. But the good news is they've actually included a few more formulas for you. So they've given you formulas for volume of spheres, cones, and rectangular base pyramids. So that was something nice that they did. All numbers are real unless otherwise indicated on PSAT and SAT math. And figures are always drawn to scale unless it has this little tagline underneath it that will say figure not drawn to scale. So just a few things to keep in mind about math directions. Content. What does the content for math look like? Well, there are 3 phases, so to speak. You have the heart of algebra, problem solving and data analysis, and then passport to advanced math. Now that sounds really exciting and kind of exotic, doesn't it? I'm going to tell you, I don't want to disappoint you, but it's not terribly exciting or exotic. But we'll talk about why they use that term in just a minute. Tahiti is not on the menu though. So heart of algebra, is that like, oh, be still my beating heart because of algebra? Probably not. What the heart of algebra means is in the past and with the ACT still, you have to know a lot about a little, so to speak. So you have to know a lot of types of math, but you only need to know a very shallow amount of a lot. Here, with the heart of algebra, you need to know less, but more in depth. So it really kind of is getting to the heart of algebra. So you don't need to know as much. It's consolidated, but you need to know it at a deeper level than you've had to know in the past. They really want to see if you can analyze and solve equations and systems of equations. They're looking for your ability to create expressions. Equations and inequalities represent relationships between quantities and to solve problems. And then they also want to see if you can rearrange and interpret formulas. So that's what the heart of algebra is all about. Problem solving and data analysis. Okay, this is everyday kind of math for the most part. Can you create and analyze relationships using ratios, proportions, percentages, and units? Can you describe relationships shown graphically? So there's that graph aspect again. So we're going to have graphs through all three sections now. And then can you summarize qualitative and quantitative data? And these two words, those are two words that could show up on our frequently confused words slide for strategies in writing and language. Qualitative versus quantitative. They sound very similar, but they are similar in that they are measuring things, but one measures with numbers and one measures more with kind of your perception, so to speak. So let's look at that. Let's take a cup of latte. So if I were going to give you a qualitative summary of my latte, I would say that, oh, my latte, it's got this fabulous, robust aroma. It's really frothy, and it's wonderfully strong, and I drink it in a burgundy cup. But Jason over here could come in and say, that cup's not burgundy, that cup is red. And you call that strong? That is weak. And frothy? That's creamy, that's not frothy. And I would say it kind of is a weak in smell, certainly not robust. Well, okay, that's what Jason thinks. Not what I think, but that's what Jason thinks. So that's qualitative. But quantitative, my latte is 12 ounces of latte. It's 150 degrees serving temperature. It's being served to me in a cup that is 7 inches in height, and I paid $4.95 for it. Jason can't really come in and argue those facts because I have numbers supporting that. That's quantitative. So the difference between qualitative and quantitative. Most of y'all probably already have that, but it might help you keep it straight when you're a little stressed and not thinking straight sometimes. Think about a latte. It smells kind of good. All right, passport to advanced math. So is this where we jump off and go to Tahiti? I know we're all wishing that we could jump off and go to Tahiti right now, but it in fact is not. With the passport to advanced math, that's in fact 28% of the types of math you will see on the test, is this. They have identified 16 questions between the two sections, section 3 and section 4, and these 16 questions cover topics that have great relevance to college and career work. So they've identified these 16 questions as a really good indicator of college and career necessary math. They need you to rewrite expressions using their structure, create, analyze, and solve quadratic and higher order equations, and manipulate polynomials purposefully to solve problems. Let me just do that again. Manipulate polynomials purposefully to solve problems. There are a lot of P's in that sentence. So as fascinating as that was, it doesn't quite live up to the Tahiti expectation. Then we have additional math topics. It's 10% of what you're going to see. These are your area and volume calculations, investigating lines, angles, triangles, circles, theorems. It's your geometry and your trigonometry. This slide right here, I just figured, since we keep talking about these graphs, probably should be able to see a pretty graph, a colorful graph in math. And this is just your pie chart for how it looks. So as you can see, passport to advanced math, problem solving, data analysis, and the heart of algebra, they all are about equal in what you see, and then you've got that little sliver of geometry and trigonometry as well. Okay, so we've kind of seen the overview of math. Let's jump into our general strategies for approaching the math that we're going to see on the PSAT and the SAT. So the primary approach is you can solve directly. What is the slope of a line that passes through the points 5, 3, and 2, and 4? You're directly solving that. That's your approach. Or you can approach the solving of that problem indirectly. You can utilize the answer choices that have been supplied. You could work backwards. You can make a simpler version, or you could make up your own numbers. Obviously you can't make up your own numbers if they've given you the numbers, but if they've given you variables, it's highly beneficial at times for you to drop numbers in for those variables, and it becomes much easier to work that problem. Okay, If you haven't retweeted anything before now, then I hope you'll retweet the middle way. This is a great tip. This and the bracket tip are my two favorite tips within the whole presentation. The middle way, remember we talked about that indirect approach and to use your answer selections. That's exactly what this is. So if you're going to use your answers, start in the middle. Notice that your answer choices increase from A to D. They will always generally increase, or at the very worst, they'll decrease, but they will always be sequential and least to greatest or greatest to least. So what you do is you take the middle, in this case it's C, and it's even better now because you only have 4 answer choices instead of the 5 that we had in the past. So you take C and you plug it in to see if that number is correct. So what this problem is saying is there were 200 tickets that were sold for a concert. Some of the tickets were $10, some of them were $5. Total ticket sales were $17.50, and they want to know how many more of the $10 tickets were sold than the $5 tickets. So we just take that 100, we multiply it by times 10, the $10 tickets. That gives us 1,000. Then we multiply it times the 5, which gives us 500 for a total of 1,500 in ticket sales. So we know that the answer is D, right? Because C is too small, and B and A are even smaller than C, so our answer has to be D. Makes it really quick and easy. So again, go ahead and retweet that. I know y'all are on your phone, so you might as well do something PSAT oriented with it. And if you haven't downloaded the SAT of the Day app, then go ahead and do that too. I know it sounds kind of nerdy, but it will actually help you long term. All right, that second indirect approach, make up your own numbers. All right, so complicated problems can be made simple if you try to understand them numerically instead of abstractly. So if you tell me to solve for n, I'm like, n, what is n? But if I can put a number in place of n, then all of a sudden it comes to life a little bit better. So I have Saul, and he works at a local athletic store, and his store has a sale on everything in the store, and it's discounted 30% off the original price. Well, because he works there, he also gets an employee discount of 10%. So we need to know what represents how much Saul will pay for clothing items that would sell for N dollars at their original price. Now keep in mind, Saul is only going to pay 70% of the total value because of the 30% sale that they have. But then he's only going to pay 90% of the 70% because he's got that additional 10% off. So we would set it up at he's paying 90% of 70% of N. That's kind of tough to figure out. But if I say 9.9 times 0.7, that in fact gives me 63N. And look at that, ta-da, there is my answer choice, D. So we put numbers in place of, and it made it much easier to solve. So that's our second indirect approach. Look at it, you know it, it's right there on the tip of your tongue. Oh, it's there, it's there. It's work backwards. Yep, I know, right? So obvious, how could you have not seen that? It took me a while, trust me, but I won't ever miss it again. And this is, we talked about that as well, it's an indirect approach, and sometimes the last piece of information that you receive is the most useful piece of information, so you can work backwards. And what we have here is one of those word problems we all know and love, and we have somebody that's making a dog run for his dog. We know that the length of the run is 5 less than 3 times the width. We need to know how many feet of fence does Tonks use if the area of the dog run is 197 square feet. All right, so we have that information, and we basically just need to work backwards to figure out how many feet of fence he needs to do it. And it's much easier to use it working backwards because we know about 1,197 square feet. That was really important, so it helps us figure it out. So it would have been hard to do with just knowing that it was 5 less, 3 times the width. So working backwards can be very beneficial. Computational tricks. PEMDAS. Dear Aunt Sally. Oh, we all know and love Dear Aunt Sally, right? Isn't it amazing that we all have a Dear Aunt Sally? Most of us anyway. If you didn't have a Dear Aunt Sally, then you may have just learned PEMDAS. So all it is it's telling you to do parentheses, then all your exponents, your logs and your roots, then multiplication and division, and then addition and subtraction. So we are going to recommend that you take it well, you're going to kind of ramp up Aunt Sally, so to speak. So because multiplication and division are on the same order, you can make your numbers smaller by dividing before you multiply. You can also take your subtraction and change it to addition so you can add in workable pairs. So it looks like this. Perform your division before your multiplication. So when we first look at this, we're like, what is 1/2 of 3? Well, we don't need to know what 1/2 of 3 is because we know that 1/2 of 50 is 25. Well, there we go. 25 times 3, 75. It's much easier than trying to figure out what 1/2 of 3 is. Let's look at subtraction and addition. So we have this, and what we've done here is we've just kind of grouped everything a little bit differently so that we have our negatives and our positives. Now, I will tell you that this is one way to work the problem. You may have a completely different way to work this problem, and that's fine as long as what you come up with is 48. It doesn't really matter how you do it, but if you weren't sure how to approach this problem, then this is one way that you could go ahead and tackle that problem. So fractions. Remember to cross multiply when a fraction is equal to either a fraction or a number. All right, so we have this 2n over 25 is equal to 10. And in essence, what we're really saying there fractionally is 10 over 1. So then we can go in and we can do our cross multiplication and we end up with what? 2n times 1 equals 25 times 10. All right? Then you can also just do the straight dividing across. And so what we did here was we had the 12a squared over 8b divided by 3a over 4b, which we do our division, comes up to 4a over 2, which ultimately ends up being 2a. Fractions, simplifying fractions, and cross-cancel before you multiply. So let's look at this. We have 15x over 30 times 12 over 7x squared. So we know that 15 will go into 30, right? So that gives us 1x over 2. And then we multiply that by 12 over 7x squared, which then gives us what? We're going to cancel out. What can we cancel out further? Right? Now we can go and cross out our x's. And so it ends up being 6 over 7x. Perfect. Numerators can be divided, and then the denominator's denominator can be divided to the numerator. It's kind of fun to say. Makes me feel like an announcer instead of a Michelle in a box. So with that, we have a over a to the 4th equals, then we put numbers in there, right? So we have 1 over 1 to the 4th. Well, if we cross out, guess what happens? 4. Now, if only the PSAT math were as simple as our examples are, we make our examples simple so that you can actually see the rules, so to speak. Unfortunately, it's not going to be quite that easy, but you won't have any problem because you will have practiced and prepared to succeed on the PSAT with all of this information. All right, let's look at percent and scientific notation. So let's look at percent first. When trying to find how much you pay from a percent discount, multiply by 100 minus p, p being 4%. So let's look at it this way. How does Stuart pay if he gets a 20%, or how much I should say? We don't know how Stuart pays. Cash, check, credit card, or maybe it's Apple Pay at this point in time. How much does Stuart pay if he gets a 20% discount on a $93 purchase? 80%, right? We just want to say, what is 80% of 93? Because a 20% discount is in fact 80% of the whole. So we would say 0.8 times 93 equals 7.4. On to scientific notation. Woohoo, we are having so much fun. Here we go. Scientific notation can be computed by parts. So let's look at multiplication. So we have all of these numbers and their number powers, right? Or their letter powers, I should say. So when we plug those numbers in, and we have 5 times 10 to the 3rd times 4 times 10 to the 5th equals 20 times 10 to the 8th. Now what's wrong with that? Remember, in scientific notation, the first number always has to be between 1 and 10. Is 20 between 1 and 10? It isn't. So what we have to do is we have to make 22, and when we do that, that makes 10 go to the 9th power instead of the 8th power. So that's the thing that you have to remember for scientific notation, if you don't already know it or remember it, is that the first number has to be between 1 and 10. If we look at division, Then there we are with our numbers and their letter power, our letters and their letter power. Then we plug in real numbers and we do our division. But we were good here because our first number was in fact between 1 and 10. All right, here comes a really big, busy slide, sort of. Has a really big word in it. Unit analysis, dimensional analysis, and stoichiometry. It only took me like 15 times of practicing that to actually get it right. And I'm still not sure I have my enunciations in the right place, so giggle and carry on, so to speak. Pay attention to units as they can cancel when divided by each other. So here's the strategy. You want to set up a conversion problem by multiplying a series of fractions based upon the analysis of the units, because we need to pay attention to when those units cancel each other out. So one of our other love 'em or leave 'em word problems is, how many liters of fuel will a jumbo jet use during a 2,332-mile flight from New York to Seattle? If its average speed is 550 miles per hour and it uses 4 liters of fuel per second. So how are we going to set that up? It's going to look like this. All right, and then we need to go through and see what we can cancel out from a unit perspective. So we can cancel hours, we can cancel minutes, and we can cancel seconds, which leaves us with 232 times 60 times 60 times 4 liters divided by 550. All right? All right. Trigonometry. So trig is not really so bad when it comes to PSAT and SAT. First of all, there's not going to be all that many questions. Remember, it's only about 10%, and it's not all 10% of it is trig. How many of y'all already kind of know a way to keep the SOHCAHTOA straight? Great. I'm sure a lot of y'all have learned about the hippie. A few of y'all know about the Indian chief SOHCAHTOA. Or you can just kind of memorize this visual right here, where you have a big S and then O over H, the big C, A over H, and the big T, and O over A. So why do we have O over H and A over H? Because that tells you how to set the problem up. So if you have to solve for sine, then you know that it's opposite divided by hypotenuse. If you have to solve for cosine, it's adjacent divided by hypotenuse. And if you have to solve for tangent, then it's opposite divided by adjacent. That little toothpick with the olive in it looking symbol, the theta symbol, that symbol is your indicator for where your opposite is and where your adjacent is. Because remember, our hypotenuse, it never moves. It is, in fact, always the hypotenuse. So the theta will tell you your O and your A, but then by remembering the SOHCAHTOA, you remember how to set those up to solve for them. So pretty simple. I mean, it really is kind of that straightforward for trigonometry on the PSAT. Good news, yay, little happy place. Quadratics. So ax squared plus bx plus c equals 0. So we solve quadratic equations by factoring, completing the square, and the quadratic formula. So how many of y'all have already memorized the quadratic formula? Okay, right? And then some of y'all are like, no. So if you have, great. If you haven't, try. Sometimes it just won't stick. But if you're practicing a lot, you're probably going to memorize it by nature of working in it so much. The real thing that you need to remember about the quadratic formula is the important information is under the square root, right? It's going to tell you how many solutions you have, the number of your solutions. So that's the important part of that quadratic formula. Not to say that the other pieces aren't important, but that's your really key indicator right there, what's under the square root. So moving on from quadratics into factoring. We're not really moving on into quadratics, we're moving into quadratics with factoring, so to speak. So here we are, we have if n times 3x minus 2 times x minus 4 is 0, and x is less than 0, what is the value of n? What is the value of n? Thinking. Okay, let me help you think. So either the n, the 3x minus 4, or the x minus 4. If either of the later two are 0, then x would be greater than 0. And that is in fact a contradiction to what that is saying, because we know that x is less than 0. Therefore, the n, because x is in fact less than 0, can only be 0. So the answer here is B. Here's another one. And the whole reason that we even put these up here is for y'all to remember how important 0 is when you're factoring a quadratic. All right? Know your exponent laws. So I wish that I did have a really cute little acronym or a way of illustrating it like SOHCAHTOA to help you keep those straight. But you just kind of have to know your exponent laws, and you really do need to be familiar with your exponent laws because you will use a lot of exponents on PSAT and SAT Math. And remember that fractional exponents are really just roots. Okay, you have that right there. So if you're not sure, if you're like, oh, I have forgotten that, then go ahead and circle that one so you can kind of recommit it to memory, so to speak. Here's one of those slides that has a lot to say, and I'm going to let you read it for yourself. The thing that you want to take from this slide, understand the function of each component of a function. But what I really want you to take from this slide is that you have to be fluent. You have to be fluent in working from both x and function values on algebraic expression, tables of values, and graphs for PSAT and SAT Math. So that's really what you're taking from this slide. Kind of look at that. So here's our little sample. All right, we have that little kind of, I don't even really know what that looks like. It looks like a J that has a funny tail, maybe, I don't know. So the function f times x equals x7 times 2x4 minus 3 is graphed in the xy plane above. If negative x is equal to k has two real solutions for some constant k, which of the following represents all possible values of k? The answer is D. Why isn't the answer A? Because f in this particular problem is negative. If it hadn't been negative, if it had just been f, then the answer would have been A. So again, be fluent. Okay, let's take that fluency into a math section quiz. It's going to be 15 minutes. We're going to do math test 1 with calculator. So go ahead and find that. You may use your cell phone if you didn't bring a calculator today. Remember, your cell phone cannot go into a PSAT or an SAT, but you can use it for today. If you finish before the 15 minutes, then go ahead and score on your own. Everybody there? And begin.